Okay, so this is the final part of differentiation. Let's have a look at some questions to do with stationary points. Now just remember that stationary points are the points on a curve which are either a maximum or a minimum, okay? So in order to find that, I need to first of all differentiate, okay? I need to set it equal to 0. I need to solve that equation, and that's how I find my stationary points, okay? Usually this is only enough to find an x value, but to find the corresponding y value, I'll just stick it in my original function. Let's do an example. Let's see what we've got, okay? So let's try y equals x cubed minus 6x squared plus 3x minus 8. Let's find the stationary points of this function here. So first things first, I need to differentiate it. So I'm going to differentiate it. So dy by dx is equal to 3x to the power 2 minus 6x plus 3. Now, if you've just come from the last video, that feels suddenly very easy compared to the last sort of few examples that we've been doing. Okay, but now what I need to do is actually set that thing equal to 0. Okay, so I can say a stationary point, or SP for short, will occur when the derivative function, so my gradient function if you like, is equal to 0. So I'm going to take my 3x squared minus 6x plus 3, that's my derivative, that's my stationary point, that's my gradient function, and I'm going to set that equal to 0 and try and solve it. Well, first things first, I notice here this is just a straightforward quadratic. I can divide 3 by 3 to end up with x squared minus 2x plus 1 equals 0, okay? Then that's fairly straightforward. That's just going to be x minus 1 times by x minus 1, or x minus 1 all squared, gives me 0, which means that x has got to be equal to 1, okay? So that's the x coordinate of my stationary point. By the way, if you're a bit rusty on solving quadratics, there's loads of videos on my channel which you can go away and have a look at and revise yourself of, okay? So, okay, so x is equal to 1, that's the x coordinate of the stationary point, but I need a y coordinate. So to find the y coordinate, all I need to do is stick x equals 1 into my original function. Because my original function says, you give me an x value, I'll find you the corresponding y value of that point. So if I stick x equals 1 into that function, okay, I get y equals 1 cubed minus 6 times by 1 squared plus 3 times by 1 minus 8. Okay, so let's have a look. So I get 1 minus 6 plus 3 take away 8. So 1 plus 3 is 4. Take away 8 is going to be negative 4. And then I need to take away another 6. So that should be equal to negative 10 as long as I've done my calculation correct. So the stationary point is going to be 1 and negative 10. Okay, so that's going to be the stationary point of that function there. Now, we're not asking for the, so if we want to determine the nature of this point, then all I need to do is just differentiate again. So if I differentiate again, then I just simply take this function which I differentiated, the 3x squared minus 6x plus 3, and I need to differentiate it. So 3x squared differentiated is 6x. Okay, if I differentiate the minus 6x plus 3, that's just going to be negative 6x. Okay, so I'm just going to get 6x minus 6. Then all I need to do is stick in my stationary point. So I've got x equals 1. I'm saying d2y by dx squared. Well, okay, if I stick in x equals 1 in here, I get 6 minus 6. That's equal to 0. So I'm pretty sure this is going to be a point of inflection. So in other words, it's going to be a curve that looks like this, and the stationary point is there. Okay, so I don't know whether it's increasing or decreasing, but my point is that it's this point of inflection. Okay, so it's kind of a flat point of that curve. It's not a maximum or minimum. All right, let's have a look at another example then. So let's have a look at this example here. Let's try y equals 6x squared minus 2x cubed plus 48x. So let's first of all differentiate this. So dy by dx, that's going to be equal to 12x minus 6x squared, sorry, plus 48. So now if I try and solve this thing, so I'm going to say a stationary point will occur when this thing is equal to 0. So the dy by dx, which I've just found, when that's equal to 0. So if I have 12x minus 6x squared plus 48 equals 0, let's see what I get. Well, first of all, I'm going to rewrite this so it looks a bit more like a quadratic. So it's going to be 6x squared minus 12x minus 48 equals 0. Okay, so just multiply through by negative 1 and put the x squared term at the beginning. If I divide everything by 6, I get x squared minus 2x minus, is that, hang on a minute, that's 8. Of course it's 8. Okay, so my apologies, my brain wasn't working there, is equal to 0. Okay, so now I just need to try and factorize this. So let's see, x minus 4, x plus 2 I think would work there. So that means that I have two x values, so I have two stationary points, so x equals 4 or x equals -2. To find the corresponding y value, okay, well when x equals 4, if I stick x equals 4 into this equation, then I get myself 160 as my y coordinate. And then if I use x equals -2, same kind of idea, x equals -2, stick it into my original function, then I get -56 as long as I've calculated that okay. So in other words, my two stationary points are going to be 4, 160, and my other stationary point is -2, -56. Now if I want to determine their nature, I want to determine whether they're a maximum or they're a minimum, I need to differentiate again. So in other words, if I say that dy by dx, I'm just going to actually rewrite down what my dy by dx was, so I don't have to keep scrolling up. That was my 12x minus 6x squared plus 48. So that was 12x minus 6x squared plus 48. So therefore, if I want to find the nature, I'm going to have to differentiate again. So if I differentiate this again, so dy d2y by dx squared, that's going to become 12 minus 12x, like so. Okay. Now I'm just going to see at each stationary point. So I had two stationary points, had one when x was equal to 4. So if I try when x equals 4, then I get d2y by dx squared, then all I need to do is basically stick 4 into that equation. So I get 12 minus 48, that's equal to -36. Well, I know that that is less than 0, which means that that point there must correspond to a local maximum. Okay, so because I know that the derivative is negative, basically means that the rate of change of my derivative is getting less. That only happens if there's a maximum. Okay, I'm getting smaller. Okay. Now, if I try my other x coordinates, what was my other x coordinate? It was -2. Okay, so if I try x equals -2, then in that case, d2y by dx squared. Well, that equals, let's stick -2 into my 12 minus 12x business. Then I get 12 minus 24. That's equal to, sorry, 12 plus 24, because of course we've got 12 minus 12 times -2. That's going to be 12 plus 24. That's equal to 36. I know that's positive, which means that that must correspond to a local minimum. Okay. So let's have a look at another example of finding the stationary points. Let's have a go at this one, okay? So let's have a go at finding the stationary points of f of x is equal to x squared over 1 minus x. Let's try differentiating this and find the stationary points of this function here. Okay, so let's differentiate first of all. Okay, so if I differentiate, it's going to be the quotient rule, because I have a quotient of two functions. So that's u, that's x squared, and that's v. That's equal to 1 minus x. So if I differentiate these things, so the derivative of u, that's equal to 2x. Derivative of v, that's equal to, well, it's just equal to -1. So therefore the derivative, let's think, it's going to be the derivative of u, which is 2x, multiplied by v, which is 1 minus x, minus derivative of v, which is -1. So I'm just going to put positive there. So positive, so negative times negative becomes a positive, times by the u, which is x squared, all divided by v squared, so 1 minus x all squared. Okay, fantastic. So I know that a stationary point will occur when the derivative, so in this case f dash of x rather, is equal to 0. So I'm going to basically set all of this thing equal to 0. So 2x, 1 minus x plus x squared, all divided by 1 minus x all squared. That has to be equal to 0, okay? That's the only way a stationary point can occur. Now just think about this. The only way that I can get 0 from dividing two things by each other is if the numerator is 0, okay? That's the only way. 0 divided by anything is always 0. Now if you're saying, well, why can't there be 0 on the denominator? Just think, if I have something divided by 0, so let's say I have, for example, 3 divided by 0, check it out, stick it in a calculator, see what you get. You'll get an error, because the reason being is because 0 can go into 3 as many times as you like. It's not defined, okay? So therefore, the only way that this fraction can equal 0 is if the numerator is equal to 0. In other words, 2x times by 1 minus x plus x squared has to be equal to 0 in order for there to be a stationary point, in order to find the value of the stationary point, or the coordinates rather. So I'm just going to expand this out, see what I get. So I get 2x minus 2x squared plus x squared equals 0. So let's think, so negative x squared plus x squared, that's negative 2x squared plus x squared, that's negative x squared. And I have 2x minus that equals 0. Let's do a bit of factorization. So I get x multiplied by 2 minus x equals 0, which means that either x equal to 0 or x is equal to 2. So to find the corresponding y's, all I need to do is just stick those two values in. So first of all, I'm going to take x equals 0 and I'm going to stick it into my original function. Let's see where it is. This is my original function. So if I stick x equals 0 in there, I just get 0 divided by 1. That's still 0. Okay. So in other words, my y is equal to 0 for that one. If x equals 2, let's see what I get. Well, I get 4 on the numerator, and I get 1 minus 2 on the denominator. That's going to be equal to negative 1, so it's going to be negative 4, okay? So it's going to be negative 4 as my y. So therefore, my stationary points are 0, 0, or 2, negative 4. It's not actually asking us to find the nature of these points. I think it's a little bit more tricky because I need to differentiate again, and we haven't really got time, but hopefully that makes sense.